Hello everyone. Today we're going to be talking about the distance formula, an expansion of what we were talking about yesterday. So, start things off. Let's suppose we want to find the distance between 2 points in a coordinate plane, such as these 2 points drawn out for you, point 2, 6 and point 6, 4. We can't exactly take a ruler and look at the distance between these 2 points, just like we can't really count the boxes between them and hope that any fractional boxes make sense. But the way that we would do this is to transform this into something that we've seen before. We're going to transform these 2 points into a right triangle. So first things first, we're going to connect these 2 points. By connecting these 2 points, we're essentially making our potential hypotenuse. And folks, forgive my curved lines, touchpad limitations. That's going to be our hypotenuse. Now we're going to draw our 2 legs. For the first leg, I'm going to take from my red dot, I'm going to draw a line down until I hit the y value of the second dot. So, from the red dot down until I hit that 4. For the other leg, I'm going to look at our blue dot, and I'm going to draw a line to the left until I reach the x value of the previous dot. Like so. Now, we basically have a right triangle. And if you may recall from middle school, the way we find the distance of a hypotenuse is to apply the Pythagorean theorem, which you may recall was a squared plus b squared equals c squared. And so the distance on our red leg here, well, that's from 4 to 6. That's going to be 2. Our distance on the blue leg, that is from 2 to 6. That's going to be 4. So Pythagorean theorem in this case would put us at 2 squared plus 4 squared equals c squared. Okay? So 4 plus 16 is equal to c squared. 20 is equal to c squared. Last step, take the square root of both sides. Square root of 20 is equal to c. And that's going to give us some sort of decimal answer. It's not very pretty, but it would tell us that the distance between these 2 points here is the square root of 20. Functionally, all points in a coordinate plane have x and y coordinates. As such, we can apply the distance formula we talked about yesterday, distance on a number line, to find the relationship between the x values and y values of each coordinates that we need to look for. Once we have those coordinates, we can then stick them into the Pythagorean theorem. Consider this. This triangle has points A, B, and C. We're going to find the distance between A and B by following the Pythagorean theorem, which we know to be a squared plus b squared is equal to c squared. Or, in terms of this triangle, AC squared plus CB squared equals AB squared. Because these are the segments that make up the 2 legs and the segment that makes up the hypotenuse. Our figure also gives us the distances, the lengths of each component part as part of an absolute value. So AC, we could substitute that with parentheses, absolute value of y2 minus y1, close parentheses, close, squared, plus parentheses, the distance of CB, parentheses, x2 minus x1, close parentheses, closed, is going to be equal to AB squared. Now, at present, we can't do anything with y2 and y1. We can't do anything with x2 or x1. We can't do anything with our squared value there or the squared value there, but we know the distance between A and B must always be positive. We know it has a squared value here. And folks, we're looking for the distance between A and B. We're not looking for the square of the distance of AB. So we have to do one more step and take the square root of both sides. So the square root of the absolute value of y2 minus y1, close squared, plus, open parentheses, the absolute value of x2 minus x1, absolute value close, squared, is equal to AB. This in turn leads us to our distance formula equation, such that if P has coordinates x1, y1, and Q has coordinates x2, y2, then the distance between P and Q, let's say this distance here, is equal to the square root of x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared. The order of the x and y coordinates in each set of parentheses is not important. What is important is consistency. Don't swap your points around, okay? That's the most common error I've seen with these sorts of problems. Make sure your x1s and x2s don't get mixed up with each other. But this method allows for us to solve distances between points without having to graph them. Now we're going to do some guided practice, 3 of them. Guided practice number 1. We want to find the distance between C, which is located at -4, -6, and D, which is located at 5, -1. For simplicity's sake, I'm going to designate this first point C as our x1, y1, and the second point D as our x2, y2. Now let's apply the distance formula. The distance between C and D is going to be equal to the square root of x2 minus x1, parentheses, squared, plus y2 minus y1, close those parentheses and square that. So we have our equation, we have our values. Let's plug some things in. So CD is equal to the square root of x2, so 5, minus a -4 squared, plus y2, which is -1, minus a -6 squared. And folks, remember, when you subtract a negative, it's the same as adding a positive. So we can rewrite this. CD is equal to the square root of 9 squared plus 5 squared. 9 squared is 81, 5 squared is 25. So square root of 81 plus 25, such that CD is equal to the square root of 106. Now folks, for this sort of problem, for this sort of guided practice, it wants us to find the distance. It's okay if we leave it as the square root of 106 for this problem. Same sort of thing with the next problem. In general, theoretical problems, square roots are okay. Real world problems, we're going to want to try to find a more exact answer. So let's take a look at guided practice number 2. Find the distance between m, 2, 4, and n, negative 3, negative 2. Well, first things first, we've got our x1, y1, x2, y2. In this case, mn is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared. Let's plug in some values. Mn is equal to the square root of negative 3 minus 2, close parentheses, squared, plus negative 2 minus 4, close parentheses, squared. Let's simplify things down. Mn is equal to square root of negative 5 squared plus negative 6 squared. Now folks, notice I've got these parentheses here with the negative sign inside. The reason why, folks, when we did our simplification of negative 3 minus 2, we got negative 5. That negative 5 was inside these parentheses with this squared on the outside. So let's now solve for that. This is the same as the square root of 25 plus 36, which is the same as the square root of 61. Again, for this sort of theoretical practice problem, square root symbol being left in is perfectly fine. But now let's look at a real world problem. Football. I'm told Texans love football. At least my high school in Texas was all about football. Now I've gone ahead and I've highlighted some key words here, some key points. Luke is standing on his team's 20-yard line, 5 yards from the sideline when he throws the football. Xavier catches on the other team's 40-yard line, 20 yards from the same sideline. Now folks, for those of you who don't follow football, like myself, a football field has 100 yards across, but it goes 10, 20, 30, 40, 50, 50 being at the midline, and then from that 50, 40, 30, 20, 10, back to 0. So when we say here, the other team's 40-yard line, that's the same as saying 60 yards from our line. So through this word problem, we have 2 points. We have point L for Luke, who is 20 yards in and 5 yards up. And we have Xavier, point X, who is 60 yards in and 20 yards up. We want to figure out how far did Luke throw the football. Now in this sort of problem, we're going to have to approximate things. We're going to have to solve for whatever the square root is, even if we have a messy decimal. But we're going to follow the same protocol. We're still going to use our distance formula. So first things first, we need to designate our x's and our y's. So because Luke is the first person we're talking about, he's going to be our x1 and our y1. Xavier's our second person, so he's going to be x2 and y2. What's the distance between L and X? Well, that's going to be equal to the square root of parentheses x2 minus x1 squared plus parentheses y2 minus y1 squared. Let's plug in some values. Distance between L and X is equal to the square root of parentheses 60 minus 20 squared plus 20 minus 5 squared. Now we're going to simplify things. Let's make that smaller so we have more space to work with. Well, Lx is equal to square root of 40 squared plus 15 squared, which is the same as the square root of 1,600 plus 225, which in turn we simplified down to Lx is equal to the square root of 1,825, which is approximately, if we use a calculator, 42.7 yards. That, folks, is how we do the distance formula on a coordinate plane.